Okay. Okay, everyone, guys, let's talk. I think I observed you've been writing some Spark code. You're able to read different file formats, Parquet files, JSON files, or even CSV, different files. Spark can read a lot of sources, guys, a lot of sources. So So your job that you're writing in notebook that can be scheduled, that can be scheduled. You will see in coming classes using some tools like workflows. You can schedule the jobs. Scheduling is very simple. Say, hey, this is the task, and this is the notebook. So your notebook can be attached to a task. Task is just a definition. Run this as a job, run this as a task. Job means job can have multiple tasks. Task one, task two, task three. Okay. This job has a three tasks. Task one, run this notebook. Task two, run another notebook. Task three, run another notebook. And start this job every day at 5 p.m. That's it. That is what the scheduling tool all does. If you know any scheduling tool, including Cron tab, which is a Unix, that's where it started. You schedule the jobs, run at a time, run at one frequency, batch jobs. So it runs every day or batch or every hourly. You can specify. So this is a batch. So in industry, there are some use cases. Some use cases, Anush, you might need a is near real time data, right? Suppose your company has an e-commerce site. You companies users come to e-commerce site, trying to buy the products, trying to add to cart, but some are not checking out. So they're just adding cart. Even we do many times. Even I add many cart, but I don't buy. Anush, have you done any time? You add to cart, you didn't buy?
Yeah, several times.
Okay, several times. That sounds cool. You are like me. So, y- so your company wants to know whether it's a just a consumer behavior or an issue with the website. Sometimes if some website has is weird, you can't check out properly because it confuses people. Mm. Eh, So they might want to see the data. The e-commerce system is a separate systems. Your analytical systems are Databricks based systems or any other analytics systems. So your company chief revenue officer or marketing officer, they want to know what is happening. People are adding to cart. So the data, Raju, Manati, Murali, Naina Lahari, look at that data is flowing into a system. So how it flows, how you read it and even display to dashboards. Okay, forget about display dash. At least how you bring it to table. If you can bring it to table, they can connect it to dashboard. So it means your data should flow from that e-commerce system should send the data to some systems like pub subsystem, publish and subscribe system. Your e-commerce system should publish this data. And a system like Kafka, they publish a system like Kafka, where they can retain the data for some time, a week. So you publish it to Kafka. Then your Spark system, your Databricks system, should be in a position to read from this. It's like a water. In Texas, you see water tanks. So some water will be coming from sources to the water tank, and this water tank water goes out to different communities or colonies. So that's it. Very simple. But only thing is, yeah, as you publish to the Kafka systems, your streaming job is running continuously. Lahari, can you imagine this? It's running. See, your
Mm,
batch, correct? If you imagine the difference between batch, uh, I think Subhashini left, maybe some issues. Shiva, you want to put a message in the group? Hey, Subhashini, we lost you.
yeah, I'm still here.
Oh, you are here, maybe. Sorry, I could not see. Uh, okay, sorry for that. Okay, I thought you have some system has some issues. Okay, great. Okay, so we haven't lost anyone. So your batch job, what you're doing is the data is sitting on the disk. You're running it maybe every day or every 10 hours, every 1 hour, or every 30 minutes, every 15 minutes, every 10 minutes. So as the time is reducing, Subhashini, don't you think your frequency is increasing to read this? Right? Every 10 minutes, every 5 minutes, every 1 minute, every 30 seconds, every 2 seconds, every second, every sub-second. So it's continuously running it. So your continuous is nothing but a kind of batch that you can't even see. You can't even see because you feel it's continuous. Anyone right now you're attending Zoom. Anyone has a light in your room? Bulb is already bulb glowing. Anyone?
Yeah.
Anush, my question to you is: the bulb is on or bulb is off?
I suppose on.
Okay. Do you think yeah, the bulb is on, right? You think? Yeah. Let me say. I would say, Anush, your bulb is on and off. What do you say?
Uh, in
Okay. Let me say. When a bulb, Subhashini, Vamsi, when a bulb is on, I don't know if you know this. Your bulb is actually on and off, but it's on and off so fast
it flicker.
you can't even see it's off. You know, you always see it's glowing, but it's on and off very fast because that's how the alternative current works. It's off, on, and off. That's how the alternative current works. So, but your brain cannot see it. So here also, it's a batch job only, your continuous job. But batch of in sub-second, so you feel that it is flowing really fast, real time. So your streaming job is nothing but a batch, but it's a micro batches, micro batches. Subhashini, can you get that analogy, Lahari?
Yeah.
Lahari?
Sorry.
Yeah. Right.
Yes.
So awesome. So that is the beauty. That is the beauty of a Spark streaming jobs. So generally in streaming jobs, Vamsi, before Spark was invented, because created, there are separate streaming softwares. So separate batch softwares. Your batch software is different, the streaming software is different. Interestingly, the Spark is called unified distributed computing. When I say unified, your Spark can do batch processing, your Spark can do streaming processing. So your streaming is nothing but micro batches running every subsecond. Okay, let's come to the point. straight.
Schedule.
Right? Yeah.
Our question.
Yeah, please.
So the question is, does it like see any program, in this case a notepad, is a notebook, right? It has to prepare its environment before it can execute a code, right? Like for example, uh, after processing few things, maybe you want to write to a file or a database or something like that, right?
Mhm.
So then it needs to acquire the database connections, things like that. And those are all expensive. So even I can understand, let's say if you're running like twice a day, then the amount of time it takes for it to wake up, prepare its environment, and then execute code, it's okay. You know, the trade-off is fine because you're only running twice a day. Let's say, but you're running every 5 minutes. Then the amount of time it takes to wake up, prepare all its environments, database connections, user, whatnot, and then after that it destroys itself, again wakes up. So in this case, does a Databricks platform provide some sort of a state management where it remembers all the connections and all that, because this is a continuous kind of a streaming thing?
That's a beautiful question. Wonderful question, Vamsi. So you are right. The first of all, nobody does every 5 minutes. That wake up, sleep, those things people don't do it. Generally, people does a 30 minutes, every 30 minutes maximum. Or some people do every 15 minutes. Then anything below 15 minutes, they go for streaming. Streaming is a scenario, there is nothing called wake up and sleep. It's a continuous wake up. So your whole machinery, the cluster will be running. Your job is, even though it's a micro job, there is nothing called wake up and sleep. It is not. It is a continuous ping, continuous ping. So your connections are your Kafka connections. Suppose this is you're reading, this is the Kafka, this is the Spark. You're reading. So these connections are persistent. And these connections to what you call the delta tables is a continuous. So you're reading continuously, you do the process, do it. So, but it takes a bunch at a time. Suppose you have this sub-second, you have 100K records, process it, put it. Next, you take another 100K, whatever that came at the time, during that time. You takes it, process it. Whatever next available, take it and do it. Take like that. So these connections persist, these clusters persist. It's a continuous running of it. Read, write, read, write, read, write, read, write. Continuously. Your clusters are there fully. Suppose this fail after 5 hours or 6 hours. As this is running, yeah, it's an expensive operation. But they see the trade-off. That's why they don't go for streaming of all data. But few cases, few use cases, or even there are companies who does 40% of use cases on the streaming because it's so important. So everything is a trade-off. I need this data, this company needs this data, this will cost this. Yeah. Is it worth? Yeah, I need a house. Somebody saying, I need a house. Somebody buy 600K house. Somebody buy 1.5 mil house. Is it worth? Yeah, I need this. My family needs this. So there is always a trade-off. Same house that cost $1 million here, it costs $2 million in California, including state taxes. Yes, do you have to? Yes, I had to go to Meta. I had to go in person. So I had to do it. So like that, there is always a trade-off. But answer to your question, great question, Vamsi. Yes, those things are not there. What you call resetting, die, and etc. So it's a continuous read, continuous write. How does it sound, Vamsi?
Yeah, see, yeah, then that's good. So you gave me the answer saying that the application never dies. It's always in continuous listening mode. If it is anything below 15 minutes, that's the kind of a practice that you want to go. But let's say, it's like twice a day, it's okay to, to let the application die, right?
Exactly. Exactly.
Okay, that's nice.
Super awesome. Great
And
question.
then,
Yeah.
yes, that's
Go
good.
ahead.
So the streaming channel, is that backed by Kafka only, or do you have, let's say if it's not Kafka is not available, then what other mechanisms do you do?
So that's also a great question. So basically, you need a highly scalable a PubSub system. So industry, Kafka is the leading, but Kafka on AWS is there. MKS, Managed Kafka Service. Kafka on Azure is there. Kafka Google is there. But mostly you will be working on AWS and Azure. Apart from that, AWS has its own streaming service called Kinesis, K-I-N-E-S-I-S, Kinesis. Some customers choose that. In Azure, there is a tool called Event Hub, Azure Event Hub. That also a customized Kafka service. Some people use Databricks on Azure or Databricks on AWS, but the Kafka service, this part, will be fully managed by a company called Confluent, who are the creators of Kafka. They might use the managed Kafka by Confluent instead of managed Kafka by Amazon or Event Hub by Azure. So answer to your question, managed, some people even use on-prem Kafka, which is rare because managing it is very difficult. Most of the customer go for managed Kafka or Kinesis AWS, Event Hub in Azure. Those three are managed Kafka by Confluent. Omsi, does that answer your question?
Yeah. My question is like, yes, that PubSub, backed by Kafka, in some cases we have queue. So I'm like thinking like in most systems, right? They have connectors. So is Kafka one of the connectors? And let's say someone does an activity on Salesforce, and immediately you want to ingest it in your Spark systems, uh, or in your database systems, right? So like in that case, if the client says don't want to use Kafka, then in that case, does Databricks have these connectors that would say, okay, let me connect to Salesforce, or let me connect to some mainframe systems?
Yeah,
They have such
that's it.
bunch of
That's
connectors.
even very interesting question. See, direct connections the software supports. Spark supports direct connection to Salesforce, not to mainframe. Some SAP connectors are there. A lot of connectors are there, but direct connections are always brittle. You know, they they don't really scale well. That's why you have this middle guy,
Mhm.
Kafka. So
Okay.
something like, see here, you're buying a home. I don't buy from the seller directly, correct? You need an agent in between. So that's how the systems are. Because sometimes the source system or even Spark system dies. Then what happens is at least those systems start publishing it. This Kafka can store it, the data. So this won't be depend on this.
Okay,
So,
understood. So
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 that's
that's
all.
that's
Yeah,
idiomatic way of the better practices to
exactly.
don't spend too much time on connectors, because like you said, that brittle and not so much reliable, plus you have to depend on the vendor support in case of issues, right? Otherwise, bring the data into Kafka and then go from there, because that's proven.
Exactly. But again, for question's sake, I want to even Google before you itself, Databricks Salesforce connector. See, They're introducing Salesforce Connect. See, July 2024, they gave a more robust this one, even data. Salesforce also presents. You say database connection, sync, create connection. So some people
coming up with Lakeflow, okay, the connectors that is being built from Databricks.
introduce Salesforce Connect. That's good.
Lakeflow, yeah.
Usually connected to Lakehouse Federation, Lakeflow Connect. You see here, extending data access Salesforce. This is to give for options to wide. Here, see, they will have connections to everything: Snowflake, Databricks, MySQL, Azure Synapse, Postgre. There are hundreds of connectors. But again, trust me, that is just to give an option to people. But at least from my experience, 60 to 70% of customers use more robust architectures, something like Kafka. So that way your source systems can be, Vamsi, can be what you call 100 systems. Mongo, Salesforce, SAP, mainframe, all are publishing to Kafka. And your Databricks, you're just connecting to Kafka. See the beauty. See the beauty.
I see the robustness there. Yeah, because
Correct.
the
And moreover,
coding is
you don't
also
have to
lower.
you don't have to stream here. See that flexibility. You publish it, but you run in a streaming fashion only. You run Spark, but run it every 1 hour. Run it 1 hour. This data is here. Instead of it's connect even when that is down. When the other one is down, since whatever the data that is available in Kafka, you can at least process. So awesome. Hope I can move forward.
Yes, yes. Thank you.
Very good questions, guys. Very genuine, very good question. Okay. To think like that. Okay. To summarize, Naina, everyone, please observe. Your streaming is nothing but a Spark job, just like your notebook, right? Is reading from a source system instead of read JSON, read Parquet, it says read from Kafka or read from a table in a streaming fashion. So they use the word called read stream, read stream, read stream. So your sources are streaming sources in Spark Streaming. Like Kafka, even if files can be streamed, interestingly. You write your files onto the disk, like AWS S3 and Azure Data Lake. Once you write files, some files can be even streamed. You write to a table, tables can be streamed. You write to a data sum to a network ports can stream. So it's a very interesting concept. It takes some time to settle down in your mind. Generally, you might not have seen this type of systems in your experience. So you stay focused a little bit. It takes a week or two to settle down all these concepts. But these are very, very interesting concepts, guys. So we use the word streaming. Am I reading streaming job, streaming source? Am I reading a batch source? That's all. That's all. Naina, is that a good starting point to have that understanding? Every time you're writing a Spark notebook, you need to think, am I reading a streaming source? Am I reading a batch source? Batch source. So Harun will show you. For example, to test it, there are streaming sources called Rate. Rate is a testing streaming source where it starts sending data continuously. So it's like your Diwali crackers, right? Vamsi, have you done any crackers, Diwali? So your, what is that? Whatever that one, you put the fire, it start throwing the sparkles, right? So rate, R-A-T, rate. Rate is a source that will send the data. So that is for testing sake, because you setting up Kafka, setting up all this are difficult. So for your testing, Harun will show you. But another point I want to mention here, the idea of streaming is I read this and write to a Delta table, just like your batch. But in streaming, since it is continuously running after 5 hours, suppose it died. It means this some issue came, your job failed. Then again you restart, you should start reading from here. But when it is reading from here, your streaming job should know read from where. Where in the sense, oh, I read already million records. I shouldn't reread again. Otherwise, you'll have a lot of duplicates. That's why it maintains a folder called checkpoint state. Checkpoint means the checkpoint will be keeping tracking till what rows we read. A million rows already read. When it's restarted, it checks here, oh, I already read million. Now let me read from million, above million onwards, like that. So a checkpoint is like a kind of memory. In the sense, suppose you see, somebody took money from you, say they $1,000, they already sent you $400. So next time when they send, suppose they send only 100. Oh, then you will say, hey, my friend, you are supposed to send me 600. So how did you say, Shubha, how did you say it's 600? Because you remembered what they sent the first time, 400. Correct, Subhashni? Correct?
Yeah, Srini.
That is what your checkpoint is, nothing but a kind of a stored memory. So how much till when it failed, okay. Whenever it processes micro batches, it puts a small memory. Oh, I processed up to this rows. I processed up to this rows. I processed up to this rows. Suppose it failed. Okay. It restarted, checks here. Oh, I processed from here. I processed till this date, all this rows. Then let me start from there. Okay. Anyway, as we discuss, we will do that. So what happens is it checks the checkpoint, it restores the state, then go and read the streaming again. That's it. Very simple concept. So long story short, in streaming, what is your streaming source? Is it Kafka? Is it rate? Is it file? Is it table? How you are reading? A slight syntax difference. Read stream or something like that. Earlier you say spark.read, you will say spark.read.stream. So you will know you're reading as a stream or not. So you read Kafka, you read rate, etc. You might have a checkpoint. Checkpoint is because in the streaming, you're running it continuously. When it fail, you need a streaming. Then you need to know where you are writing it. Are you writing to the screen? Are you writing to the screen? Are you writing to the table? Are you writing to the disk S3 or AWS? Are you where you're writing, right? And last, you need to trigger it. It's like you have Diwali crackers. You will put a fire. Then only you'll get it. Just because it is there in your hand, it won't spark. So at least one time you need to trigger. That's why there is a trigger. You can cancel it, that trigger. I'll stop there. Harun, anything I'm missing? Harun, anything I'm missing to share, at least to start?
No, Srini, I think you're good. We did a very good concept. Yeah, we can continue from there.
Super awesome. Everyone, you might have a little bit challenges to understand this, but stay, Manideep, Hitesh, just stay, hang on. These are very, very good stuff. Okay, cool. Harun, go ahead.
Okay. Thanks, Srini. Just give me 1
Vamsi, let's
second.
connect
Share my
offline.
screen.
If not today, tomorrow or early next week. Okay.
Yeah. All right. 1 second. Yeah. Thank you, Srini. That was a wonderful introduction and very good discussion. So we will continue with the concepts as Srini has mentioned how the streaming works continuously as a micro batch, how it is exactly um, you know visualized in terms of Spark um, stream processing, and then we will talk about how we can trigger a sample stream that Databricks provides to test the streaming. And then we will talk about what are the various streaming things that we can create use cases with, setting up things and generate streams. So some of them are supported in our the community edition. Some streams, since we have to set up an external source where the data is streamed, so you have to create your own paid um, account to stream that data and process with Databricks that we will go through, we'll showcase, and then you can also create and practice. With that, let me share my screen, and then we will get started with the streaming use cases. Okay, any questions before we get started from our discussion today? Okay, all right. So I have a notebook here, Spark Streaming, and then I will be walking through this notebook, going through the concepts. So this is just to reiterate what Srini has already discussed, the use cases, how we are going to look at the different use cases here. So one of the use cases, if you look at Spark, right, Azure Databricks, okay. So this is where we have created our notebook. So this is very important. See where each of the component fits in, right? So you have to visualize this when you talk about any pipeline, correct? This is actually a different different representation of our medallion architecture that we talked about with source and targets, right? So if you see here, so we talked about the medallion architecture, this part in the batch. So this is where our Databricks batch processing is all happening. These are the sources that we were reading, and see we had a streaming component here. Then we had database and files here. So we were using this files for batch processing. Now we are moving on to streaming. So streaming does not always have to be a something like Kafka. Okay, so you can also stream files. So your incoming files can also be considered as a streaming source, or you can stream from databases, whatever CDC data change data capture that is being triggered can also be your streaming source, right? And on the right side, you have your BI, where you kind of read from that gold and then do dashboards and analysis and data science and all of that. So if you go back here, one typical use case that we found on the internet is basically, so this part is where your processing is happening, right? Now, instead of the batch processing, now you do structured streaming. Structured streaming is basically you're getting data in a structured format, and then it's a micro batch that you're reading as a stream, okay? If you go left, data ingestion, Azure Event Hubs is one of the what you call it's a tool similar like Kafka, where it has same publish subscribe model, where the events can be published to this. You have some storage just like Kafka, and then you can subscribe and read data from this. So you can think of it as a local storage or a water tank where water is being pumped in, and then you are taking water out of the tank. The water will be in the tank for some time as you configure, and after that you can flush out that water, something like that. If the tank in the water is there, you can come back and take water anytime you want to. Now, where the water is coming in can be the source where it is actually getting generated. So, for example, I have a weather data that I am collecting from devices, IoT, whatever, and using a Python application, I am processing all of that data and publishing to Azure Event Hub, or it can be a Kafka here. Okay, so like we see here, different things. So one of these, so the data I'm collecting, it can be the weather data, it can be the stock market data, say the prices of a particular stock that is continuously being changed, and then I'm streaming all of that data to some document that is analyzing the performance of the stocks, right? So that can be this application, and then that's streaming the data here, and we are processing using the Azure Databricks as and when the data is coming in, specifically with say some kind of latency. It can be, so since we said micro batch, so the latency can be like 1 second or milliseconds or whatever it is that we want to take the data in and process. Now that is on the left side, sources. So we have a source that is generating the events or streaming data. We have a tool or a queuing tool, NQ, model, you can say, or hub spoke model, you can say, different terminology we use, publish subscribe model, where the data is temporarily stored, okay, published, and then you can subscribe to this and start reading from here. So you're doing that processing in the Azure Databricks. What do you use for processing? Apache Spark, that we are writing our notebooks, right? Spark.read file or read, CSV or read stream that we do using, because this is streaming. Now, if you go one level below, you're processing it. Where is the data getting stored? Is in the underlying cloud platform, right? Storage, you have to store somewhere, right? So even if your CSV files, you are reading and writing to a table, but underlying, we have seen, right? When you do extended, it is showing you the path. And if you go to that path, you see all that data that you're writing to the table is stored as files, right? So you're writing it to the files, and then it is all available in the files here. This is because Azure Databricks, it says Azure Data Lake where you are storing. If it is AWS, it will be S3. Okay, the storage goes to S3, and Google Cloud, it will be Google Drive or wherever it stores. Now, this is the storage. What is the format? Delta, right? So we are storing in a Delta format, that is a wrapper around all the storage where you do your transaction logs, your asset transactions, to keep the state, time, travel, what happened in each transaction, what data was added, what was modified, what was removed, which file was added, all of that log, and all features are maintained here using the Delta on the storage. Then the actual format of the file that is stored is Parquet format, right? So this is all that is happening in the Azure Databricks with the streaming. Now on the right side, as you said, this is a serving layer. So it be a visualization. It can be Power BI, it can be Tableau, it can be another Python application, it can be a data science application, whatever it is, or it can be another database. So you write a direct query and go all the way here, Delta Lake, Parquet files, get back data, and you provide the data to the visualization. So this is the architecture landscape of a Databricks streaming application, or streaming use case, streaming pipeline, you can say, not application, streaming pipeline. Is this clear? Any questions on this? Just give me 1 second. I need to quickly step out 1 second. Any questions on this? Lahari, Raju?
All right, good.
No. Yeah.
Okay, sorry about that. I'm back. All right. So we all understood about this use case, right?
Yep.
Okay. Now let's see how okay. Let's look at this picture here. So as we were talking about streaming use cases, right? So let's see here. Again, the same Spark streaming, the sources and targets. The source, as we said, can be Kafka, Kinesis, Akka. You can stream from databases, Cassandra, MongoDB, Elasticsearch, Postgres, MySQL, HBase. These are static data sources. These are static data sources that you can read from into the streaming. You can read them as a stream. Streaming data sources also you can read as stream, like all of these Kafka, Flume, Kinesis, and Akka, all of this. Now, once the data is in streaming, you process with data frames, query interactively with SQL. So you can actually query the data while in transit. While we are still processing the stream, you can still interact with SQL, run the SQLs, do joins on those data frames, streaming data frames. You can join the stream data frame with a static data frame, which is static, doesn't change. You have fixed amount of data. Just like if you have address coming up, you have a code, you want to join with a table called states or country, and that is a static table. So the streaming data can be joined with static table, and streaming data can also be joined with another stream. Okay. You are getting separate streams of orders coming from different countries. You want to join all of those union or join those tables, or you are getting prices from one stream and then orders from another stream. You want to join these two, whatever it is, the use case. Basically, you can join join one stream to another stream of data in the data frame. You can join a streaming data to the static data, basically. So those are two formats you can interchangeably use and join the streams and come up with one new data frame. You can use machine learning while the data is streamed to train models, or use trained model with live data that is getting in. So typical use cases, credit card fraud. Okay. So when the data is being streamed, using it, so when the credit card transactions are coming in, you have to make a decision within a split of a second, or so within the second, before you whether to approve the transaction or is it a fraudulent transaction. You want to flag it and block it. Sometimes your credit card gets rejected, right? Says the transaction doesn't go through. Sometimes you get a message saying that, are you trying to do this transaction, right? So how is that happening? It's not a batch. It's not like you did your transaction, it was stored, you come back after 30 minutes, you process it, you figured out, hey, this is a fraud transaction. It's already done. Now you cannot go back and do anything, right? So that is a typical use case where streaming data, processing the streaming data live is critical. So as and when the transaction is submitted for approval for the credit card, you go through, for example, what kind of scenario. So you have a data that is coming in. You did a transaction, say in Dallas, right now, 8 o'clock. Another transaction is coming in with the same card, let's say from New York, at the same time. So which means you cannot be physically present, or the card cannot be physically present at two places at the same time, right? So there is something fishy, something's going on. So that's when you want to block it. So how do you block it? You have to check what is the transactions that are happening currently or recently, whatever data that you have. You join the stream with static data or a stream with another stream of data. Check some, use machine learning algorithm to figure out, hey, everything looks good. Then you say you accept it or you block it. So something like that, use cases, right? So that is where streaming data live, you are processing and taking decisions live on the live data, right? Everybody got that? Use cases?
Harun, I
Now,
think
yeah, sorry.
you can go with some example. Then you can discuss theory. Then again some demo
Sure,
and
yeah,
theory.
yeah,
Otherwise,
yeah. We'll
it
come back to
becomes
this.
too much for them. No.
No, yeah. So I'm just talking about source and streaming, how it is coming up. So yeah. And then the data storage systems once you process and then store here in the whatever databases or data storage systems that you want to. So this is basically how the data is coming in into the
No, again,
streaming.
Harun,
Yeah,
please
we'll come
listen to
back
me.
to this. We'll
Please
come back
listen
to
to me.
this. Yeah, yeah,
You can always discuss. You don't have to go in order.
yeah. No. We'll come back to this. Yeah, we'll go to a example. We look at the data and then
And
we'll
come back
come back
again.
here.
You can come back
Sure.
again. Yeah.
Okay. All right. So that's what we talked about here. So Spark dot read stream, right? So from the batch you talked about. So we say there are different types of streams that we can read from. So we can read from file, we can read from database, we can read from Event Hub and Kafka, right? So basically on that, so there is something called a rate format, which the Databricks provides, which generates the events, for you to read it as a stream. So it just says Spark dot read stream. Format is rate. So basically you can give different formats here for the stream, and options, how many rows you want to read per second. So let's say I want to read 100 records and load. Okay. And then I'll say display data here. So that is read. Now when I go read display, so now see here, the stream is initializing. Now I get, I'll start reading the data here. So 700 rows, 1000 rows. So continuously I'm reading the data from the stream. You can see the count is increasing. So you can only see up to 1000 here. But if you do the count, you can see how it is continuously increasing. Now it has only two columns here, timestamp and value. Okay.
Harun, I have a doubt.
Yeah, sure. Go ahead.
When data is continuously streaming, like we can see that there are 1000+ rows. What is the use of mentioning how many rows per second? Because it's always continuous, right? So
Yeah, this is the rate, right? So for this, how many rows you want to read? For the first 100 you want to read in 1 second. Okay. So after that, whatever it is, say there can be 500 rows, but you want to read only 100 rows for each batch. So you're all talking about micro batch right here. So every time you go back, trigger and read the source data, how much data you want to read. If it is files, how many files you read for each time you trigger. You go and start reading the file and getting the data. How many files you want to read for each trigger. Similarly, how many rows you are reading. It's not like continuously 1000 rows or 1 million rows are coming in, you read all 1 million in one go, right? So that is why it's called micro batch. It is streaming, but it is a batch at the micro level. So each trigger time.
Let me add
sure.
one more
Want to add
point.
something?
Naina, so there are options where you can read the whole thing that is available also. So this is a flexibility. You can read number of rows, you can fix it. You can fix number of files, you can read, or everything that is available at that time. So it's a flexibility. He's showing one of the option. But generally what happens is sometimes reading everything would, it takes a lot of effort on the systems. Suddenly you have a spike, then suddenly there is no data. So instead they will stack it up to few seconds. Instead of reading million rows in 1 second, in 10 seconds they will read those things. So you have that option so that you can keep those clusters uniformly running instead of spiking it up. You got the point, Naina?
Yeah, and it's also a client-specific use case, right? It's depending on what the client wants in terms of
Correct.
their
Correct.
data and what usage they're trying to address.
Correct. You have that options, Naina. You even have you trigger once. Trigger one means just available everything that you'll get to that point. Naina, you got that
Yeah.
point, Naina?
Yeah, sure.
Okay. All right. So this is, if you can see here, we are saying stream data, whatever is coming in, group by and count. So if you are just group by this data that is flowing in, and then you start counting, you can see the number of rows that is increasing. It's continuously increasing. It's continuously reading the stream and then processing it. Okay, so this will continuously run until you go ahead and stop it. So it's continuous stream. So you can go and say interrupt and stop. So even if you are scheduling this, the job will continuously run. And when the job ends, that's when the stream is stopped. Reading the stream will be stopped. So once we have the stream, as we said, rate, so rows per second, I'm only taking 5 here. Okay, so we want to just read a few lines of data. And then we want to do transformations. Remember, so we always do, even if it is just like batch, we can also do the transformations for streaming data as well. Now, as I'm getting the streaming data where I have a timestamp and a value. So if you can see here, the timestamp, you see what time this event is generated. Okay, it is generated 1634. This is milliseconds, 947. This is generated at 35, 147 milliseconds. This 35, 347, 35, 547. So all of this, each event is at a different timestamp, at milliseconds level, that is different. Now, with that timestamp and value is just like, running sequence that you can see. It's just a random number that it has. Taking that, I am adding few columns to the stream. So as and when I'm reading the stream, I can transform the data in those fields, columns. So for all practical purposes, once you read the stream in the memory, you can just treat it as like how you are reading with the batch. You have a data frame. So once you have a data frame, you can register it as a view, and then you can write SQLs on the view. So even though the data is continuously streaming, you can still write SQLs and access that streaming data as a static table for visualization purposes. And you can do all your transformations, aggregations, everything on the streaming data. Okay, so let's see here.
I don't know.
Yeah.
We are doing transformations while streaming, right? So what is the suggested, way to do it? Because do we want to do the transformation while publishing the data, or do we want to do the transformations while streaming the data, performance-wise? What is usually suggested?
Publishing in the sense when you're serving the data?
So no, when we are putting the data to a data source, right? Be it, so if I'm going with MongoDB, correct? So while putting the data there, or whichever data source, right? This is reading from, streaming from. So when we are putting it in the data source, is it suggested to transform it then, or while
Anush, unfortunately, we have only 3 steps. You read, transform, and load.
Okay. So we cannot skip transform.
There is nothing called in between you can stop. Just read from source and transform
I understand.
it and load it.
So the standard is to still follow everything as you do for batch, like your medallion architecture. That's the standard.
Okay.
It doesn't matter whether it is a batch or a streaming, right? Once you read the data, everything is same, except for few options where you want to do a additional configuration or additional processing or additional guardrails that you want to see for streaming data, like how much data you want to put it in the processing window before you flush out the older data. Because if you are continuously reading and having it in memory, you cannot have unlimited data in the memory, right? So you have to define how much data you want to have it in memory for processing before you write it to the database, to the architecture, to gold layer or silver layer after transformations. And as and when the window you are moving forward, the data that is older, stale data, gets flushed out. So you can define how much data you want to hold for transformations and for processing, kind of a thing. So those things are additional, but in terms of the architecture and the pipeline, how you want to process remains same. You do this, read the stream data, read the batch data, interchangeably do joins, get entire data transformations. You write it to the silver or you write it to the gold. So after that, your whatever MongoDB or whatever you want reading from the gold layer, that will still remain same. See, that is why we said, right, when one of the features of Databricks is you don't need to have separate layers of pipeline. Say I want one for streaming, one for batch, one for data science, one for machine learning. Everything remains same. Whatever data that is coming in, the pipeline, the structure, everything, the same pipeline can process both streaming and batch data. You can even join both data sets. That's what we said, the beauty of Databricks, this Spark processing. And that's one of the features. So everything remains same what you do for batch processing, almost same for the streaming as well. Does that answer your question? Okay, great. So that's why, so we are relating to the same when you go back here, right? That's what I was trying to relate. So even if it is a batch or a streaming, everything remains, everything remains same, how you process and read. The only thing is the transformations and how you process streaming data, how much data you hold in memory and all of that is what you will have to additionally take care of. Okay. So with column, so we are adding few columns here, some data to the data frame, the streaming data frame. So what am I adding? Some loan ID, funded amount, and paid amount. What are the values? These are like arbitrary, just some sample values. Arbitrarily, I'm taking some number plus this value. So this is a randomly generated number, right? So I can take this value and add it to 10,000. That will become my loan ID. Okay, 10,004, 10,005, 10,013, whatever it is. So I'm adding this data to the stream and generating a new column called loan ID. Funded amount, again, I'm doing some calculations. Random star 5,000 plus 5,000 plus cast integer. So this is the funded amount. Some amount I'm generating some random amount, saying that okay, this is the amount that we have funded to this loan ID. Paid amount is I take this funded amount column and deduct some random number again using 2000 star random. So that will, I'm calculating the paid amount. So based on these transformations, these calculations, I am adding 3 more columns: loan ID, funded amount, paid amount, and then generating this data, stream data. So I can run this and say display stream data. Display the stream data. Timestamp, value, loan ID, funded amount, paid amount. See, this is just the random amount that we are generating. And you can see continuously the data is increasing here. Okay. As and when we are going forward, since we are reading 5 rows every second. So this is continuously increasing this data. and we are generating all of this. So each job is getting triggered to read one batch, micro batch of input data from the stream and processing and displaying this data. This is good. You can also do group by here. So this is starting a new stream. This is a different stream here. So the count, and you say display. Any questions on this?
Oh, yes. Hello.
Yeah.
So for the previous example with the 5 records per second, 5 rows per
Mhm.
second.
Mhm.
So when we are doing transformations, how are we doing the transformation? Are they sequential or because our main goal is to minimize the delay from reading the stream and then loading it to another source, right?
Mhm. So that's what we said. So as and when the data is coming in, it will be
Yeah.
in the memory. So those 5 seconds, we have done the transformations. The next set of data is coming in, same transformations is done and appended to the same data frame. So it's just like
Oh,
how
so
you are seeing here.
I was talking
It
about
keeps
in 1
adding to,
second,
yeah.
in 5 records, the
Mhm.
transformations, how do they take place? Like, do you sequentially
It's a
take a single
distributed
row?
processing, right? So it's a distributed processing. Whenever you are using Spark, the
Yeah.
rows get distributed and based on
Okay.
how much. So let's say this is not 5 records. So let's say this is 100,000 records that you are reading per second.
Hmm.
So you cannot do sequentially 100,000 records, right? By the time
Yeah.
next second comes in, there is more data that is coming in.
Hmm.
So you have to do distributed. Spark by default, it does distributed processing. Again, this whole data frame is like distributed. And based on
Okay.
how many nodes, how many machines you have, this all transformations are done just like batch. The moment you read a data frame, it's distributed.
Just to add,
And then it's done in
Yes,
yeah.
yes.
just to add,
Understand.
Hitesh. So whatever that is available, that 5 or million, it does on the whole batch. So you read million, all transformations happens on those million rows in that cluster distributedly. It doesn't do sequentially. That's what.
Okay. Yeah. Okay.
Once that
Okay.
flush out, it reads another million. It does all the transformations. It's just 3 steps: read, transform, and load. Everything
So,
is happening on a whole bunch of records you are reading at that second.
mhm.
Okay. So let's see another example. Spark streaming, another example here. There's a Databricks data set, structured streaming events. So this is the delivered files by this is the Databricks. So we have this path, okay. So and it has all of these files. So these are JSON files, okay. We were all doing CSV files. Now we have a JSON file. We will talk about how to process, JSON file, parse, flatten, and all of that in the coming classes. But for now, you can just assume, okay, we are reading a JSON file instead of a CSV file. So if you look at this, select resource, streaming events. So we have all of these files here, 50 files. And each file size you have here. So we can say what is what does each file have? Spark.read. Remember, we used to do in the batch read.csv. The same thing I'm doing read.json. Okay, so I'm reading a JSON file and then I'm giving path to one of the files, file0.json. Okay. So what it has a column called action and it has a timestamp in the file. So actions can be open, close, and there is a timestamp here. So what I'm doing to read this, first I'm creating a JSON schema that's time and action. The time is a timestamp and action is a string. It's just like open and close. Path is this folder. So all the files in the folder. And then I'm reading the stream, spark.read stream. I'm reading it as a stream. Schema is whatever this, field that I have given time and action. Max files per trigger. So how many files I should pick up as a stream every time I want to read, every time I go and read from this file source, how many files I should pick up every time. So I said just take one file every time and start processing. And .json, this is what I am reading. So I give .json and path, the files in this path as a stream. Everybody got this?
Yep.
Okay. So let's go ahead and run this. Okay. So this is ready. Now I can go and start reading that. So this is the just like transformation or the redefined definition, but only when I do an action display, it will kickstart the stream. Basically, right now nothing is happening. It just defined this, what is the streaming input data frame is. So I'm reading this streaming input data frame and then group by action. Action is like open and close and what is the count. So if I start reading this, stream initialize. And see here, open 1400 rows, close 531 rows. So it's going back and reading files again, multiple files, and then appending the data together. So when you do a group by, right? So it has to recalculate the entire thing from all the files, whatever it has read, all the data in the data frame. You cannot do first 5 minutes, first 5 seconds group by one count, and then again 5 seconds another count. You cannot do go and add it. So you have to recalculate all the aggregations on all the data that is available. So every time it's reading the file, it goes back and reads all the data. And then does a group by on action. Action, as we said, there are only 2 actions in the files in the data, open or close. So what is the count is going to? It is reading every file and doing the aggregations. So continuously it will keep appending and adding it until all the data is there. 50 files are there. So once it processes all of that, then there are no more files to process. It just keeps looping and looking for new data. That's it, until we stop the job. So the count will not change once it processes all the 50 files. You get it? So whenever, say, somebody is writing the files to the same folder, whenever the new file arrives, it will automatically, because it's holding that, checking that path for new files. So once the processing is done, as soon as there are new files, it will start picking up the new files and do the processing again, those files. Okay. Any questions? Are we good to go proceed?
Yes, sir.
Yes, sir.
Okay. So, same thing what we did, basically the Amazon data that we have, the files. So last time we read it as batch. So everything we were reading at one time. The same path we can give and start reading as a stream instead of batch files. You can say start read stream. So here I'm giving whatever path I have for the files, and then I'm doing a read stream. Format is CSV. See, remember here we are reading format as JSON files. Here we are reading format as CSV. Okay. Schema is what I defined. ID, name, main category, subcategory, image link, based on what is the structure of the file. So max files per trigger is again 1. Okay. And then I am reading the files from this path. So all my files, if I want to see what files are here, I can go and see. Display dbfs.fs.ls and then path. Sorry, not to- Okay, so I have this, all the files here, 140 files that we have. Now I can go and run this Spark streaming. I will remove this. Okay, when I say display streaming data frame, this data frame, that's when the action is, and it will go start reading the set of files that we have, the Amazon files in the Amazon folder as a stream. So max files per trigger, I have put 1, so it will start reading each file, one file at a time, and then display. So you will not see because it will continuously start displaying the count. So 720 is here right now. See, now it is more than 1000. So it will continuously start reading data from those files. Now we are saying, as I said, right? So when we are start processing the files, we can still go and do whatever we are doing, same as our batch processing. So we go ahead and create our databases, bronze, silver, gold, just like we did during the batch, since we are using community edition. So they are not persisted. So we go and create again. Now, if we have this table, we go and truncate table or view cannot be found. It's not there. That's fine. This is the raw data that we are reading. And this is the extra configuration that we have to do when we are doing the streaming versus batch, because checkpoint directory. So this is where, remember, Srini was talking about to maintain the state. Hey, when if it's broken, I want to know where I have stopped, how much data I've processed, where I want to pick up. So all that internally, for it to maintain the state, we have to provide a checkpoint directory. It uses the checkpoint directory. So it's just we have to give a path. Okay, we just give a path and file name. So in the folder name where it will start writing its path. So don't worry about all of this, what it is. It's just some sample thing that it wants to generate and append to this path. Okay. We are using temp delta demo checkpoint slash some string as a folder path. So you can give any of your folder path also here, any name. So you don't have to use this string of random randint. We can check that. So basically what we are doing here, streaming data frame dot write stream. So when you say in the batch, we used to do data frame dot write. Here we are doing data frame dot write stream. So format is delta. Okay. Checkpoint location we are giving checkpoint location. Trigger processing time is 5 seconds. So every 5 seconds it processes the stream and writes to the table. And dot table we give table name. Okay. So let's run this. Open. Amazon is not an empty and also not a delta table. Okay, let's give 1102, just one name, and run this. There was already an existing path there that's writing, so we had a conflict on that. I created a new bronze raw table here, and it is writing to the stream. Now I can go %SQL, select star from, this is the path, right? So this is the table that we have created. So run this. $23,300 rows are being written to the raw table. So now 24,500. So as and when it is, the data is being read here using this data frame, right? That data is being written using the write stream. Got it? Okay, as and when the stream is continuously processing and reading here, we are writing to this delta table. Now I can also use streaming DF, whatever is coming in as a stream, and then do the transformations while it is streaming. Okay. What I'm doing group by main category count. Remember, we used to do this in batch when we wrote to raw layer, then we wrote to silver, then we read the data frame, and then we did the group by. The same thing, right? So the same thing we can also do while streaming, basically. Okay. So when it is streaming itself, you can have all the data, and then you can create cannot create. Oh, that's fine. And write to gold. So let's say 1102. Group by streaming data dot group by category, and we are writing to the gold table here. Write stream. Output mode is complete. So every time you write, overwrite kind of thing. That is what is complete. because it is an aggregation. Okay, so you cannot just update the rows. You have to overwrite based on the keys. So you're doing aggregation on the entire data, the count. So you overwrite that data. Checkpoint directory we have given, and then we can run this. So let's go and check what is happening on the gold table.
What does the output mode complete mean?
Complete is like you are overwriting the data in the table every time. You're not just inserting or appending. You are overwriting all the data set based on the new aggregations that you have. So why is that? Basically, let's say in the first 5 seconds, for example, you have got air conditioners 400, and there is another data that is coming in, that is let's say accessories is 500. Okay, so you have 2 rows, you go and write. Okay, and then new data is coming in. Now the aggregation changes, the count changes. Okay, and then there are new data that is also added. So let's say there is clothing that is coming in. So now you have 3 rows instead of 2, and then the count also has changed. Okay, so that's when you have to overwrite all the existing data. If you append, you will have air conditioners 500, air conditioners 200 again. So basically that's not an aggregate, right? You cannot just take those two and then average again. So that is why when it is recalculated on the entire data set, you just overwrite here. So that's one of the mode. We can check what are the different modes available in batch mode and what are the modes available in the streaming mode. In the documentation, we can check that. So, but for complete, it means that you are overwriting. Okay, now we have got more data that is coming in. So air conditioners, see only 720 are there, so it's not changing. The next files that is start reading, it has grocery, one file has car, motorbike, one file has electronics. So it's continuously doing that aggregations based on the category and then writing to the gold table. See, now this is entire streaming pipeline. Okay, as I see, this is running, which means streaming data frame, it is writing. What is streaming data frame? Streaming data frame is we are reading the data from this folder, one file at a time. This is the streaming DF. So from here until we are writing to the gold, now this is a continuous pipeline that is running. While the first part, it is reading the file. The second part, it is aggregating. The third part, it is writing to the gold table. So here we have skipped writing to the silver. You can still write it. It does not matter. But we are processing everything here in the memory itself. If you want, you can write to silver, and then you can also again read from silver and do the aggregation. It's the same thing. But the whole thing is it's just a streaming data that is, you are reading and processing. Got it? There are 6 rows. Now, if you have new files that it has already read, then you will get more data here. 9 rows. So now you've got appliances and electronic pet supplies. So it continuously starts, it goes on until it has read all the 50 files and it has done all aggregations and written to the database. Okay, so now we have looked at processing the rate format, which is just a sample kind of a utility. I don't know how many of you know there is something called Netcat, where you can just publish some messages using the terminal, all right? So similar concept, rate, which will just utility for testing purposes. So it just gives you the kind of generate some events and gives you, the timestamp and the number. So we have seen how we read from that. So let me refresh this. Twelve rows. Now we have baby fashion, Amazon fashion, and all of it. So basically, we have read the rate format as a stream, and then we have read JSON files as a stream, and also now we have read CSV files, Amazon sales data CSV files as stream. Okay, so 3 different formats we have read as streams. We have done transformations on the stream, basically, and aggregations. The transformations we have done here. Where is that? In the JSON file, or in the previous one, on the rate. So we have added some columns, loan, payment, and all of that transformations, new columns added, and we processed that. Here we have done read data, and then we did some aggregations, transformations, group by, and for Amazon files, we are doing group by categories here, and then writing to the gold layer. So basically read, transform, and load. For streaming, we have done continuous streaming data with 3 different formats, rate, JSON, and CSV, right? Any questions on what we have done till now? Raju, Lahari,
Nahar.
we are all good in this?
Yeah.
Okay. So we don't want to go deeper into concepts in this class, but tomorrow we'll talk about how, when we are reading the data, how does Spark process or treat the stream internally for processing purposes. And we will also go and see this part where we have Azure Event Hubs. Okay, so I will show you a demo on this Azure Event Hubs, where setting up, which I had done on the personal account, how we can publish the messages in the Event Hub, and then we can read that Event Hub data in the Azure Databricks, process, and store. And then we will also visit these how Spark processes this data, and what does the window mean, how much data you can have processing, and all of that. So it would be overwhelming today to have so many concepts, but I think it's good for you to digest what we have discussed today. And then we can talk about this, right? Okay, any more questions before? So we have 15-20 minutes. We can go back and review some of the notebooks that you guys have done. A couple of them I have looked at. We can talk about any questions you had while you were processing that or writing those notebooks. We can use this time to clarify those questions, because we can continue, but I don't want to put so many things in one session for you guys to digest. What do you think? Is that good? Mani, Hitesh,
Yeah, it's good.
you guys are clear?
Yep.
Okay, all right. Okay, so let me check this here now. Go back here. So I have gone through a couple of notebooks, Anush and Lahari's. The other ones I will do today, or maybe Shiva can also take a look at that. Anything you want to discuss, Anush or Lahari, on this? Anush, yeah, I ran this book. So basically, I ran both the notebooks. They look fine to me, good. And I can see you've used different approaches. So Anush has used SQL. Just one thing where it failed, or just a small glitch was somewhere. I think Anush has put a comment in the SQL block, not realizing. Yeah, this one, right? So when you put a comment before %SQL, it
Doesn't,
actually takes it as Python,
I
not as SQL. So yeah, I know it's just a small, yeah. So I didn't understand why it is not running. Everything looks
yeah,
good,
initially I was
you
also,
know.
why is it not taking it? And then
Yeah. Then I realized, okay, I think so. Then I put it in a different cell, and then it ran fine. I just wanted to show that. Yeah, that's fine. And also one more thing, I think in Lahari's notebook I saw. So when you write %SQL, you don't write whatever you write here is ignored after that. So just write it in the next line, whatever you want to write the SQL commands. Okay. Yeah, this all looks good. Anush, all you're doing aggregations and used round sum, all these SQL functions that you can use. This is good. You have used, I can see that, group by using the data frame SQL here in this, most of it. And any questions, Anush, you have while you are doing this? You faced any challenges or anything you want to discuss or talk about? Actually, I wanted one of you guys to walk through your notebook and demo this, but I didn't get anybody
I think
confirmation.
no, I think Harun, Subhashini volunteered that she would like to
Yeah,
walk through her notebook.
Subhashini, yes. Yeah, okay.
Mhm.
Sure. I didn't import her notebook. We can do that right now. Let me see.
Yeah, but Anush, I think a great job. We put in two
Yeah.
types, data frames and SQL. Most of that, probably we would go for the SQL, right? Most of the times.
because I'm comfortable in SQL, but I wanted to play with data frames also.
Absolutely. No,
Yeah.
absolutely. Yeah. SQL,
Yeah.
we all know. If you know the SQL, it's very easy to write it
Very
down.
simple, yeah.
Right? If in the data frames, you have to go through a little bit, back and forth, to get it
Yeah.
right, the syntax and everything. So
Right. Yeah, that's an awesome job, Anush. And then, you have the first one you did on Monday. I immediately appreciate that. That inspired our team. So most of them have submitted the notebooks. Sorry, folks, I didn't get enough time to go through all of the notebooks, but I did a couple of them. But I will do the rest of them today, or we can share. Shiva can also look some of them.
yeah.
So Lahari's notebook also I went through. I ran. I think it looked good. Interesting that Lahari has used Spark.SQL instead of plain SQL or data frame. So SQL functions, yeah, we have all done columns, queue, transformations. So it looks good, Larry. You understand all the concepts. Dot, filter, all of these.
So in business case, like usually in real-time projects, the transformations that we need to do will be provided by business, right?
Yes. No, sometimes yes, sometimes no. See, basically the business will not tell you, hey, remove the null columns. or remove. So those are some are like assumed data quality checks that you need to do. Okay. For example, quantity is a numeric column. If somebody is sending a string in that, right? So those kind of things are assumed that you do the data quality checks. The business will not give. Okay. What the business will give you requirements is, hey, unit price, I want 2 decimals or 3 decimals, right? And then when you are doing a conversion from, say, different country, okay, say you are getting the what you call Europe, some transaction are coming in from the euro currency and you want to convert to USD. So you will have some data set, that conversion metrics that you'll have. But when you're converting, it's very important to consider how many decimal places that you want to take while processing, because a lot of things go off in rounding. Okay. But if you say I have €1,000,000 and then you are rounding, it's a significant amount that will get chopped off. Okay. So those are the things that business will give you requirements. Okay. That's what I want to see. And then a requirement, you want to say country. Okay. I want to have some mandatory fields. If the country field is null, raise it as error. Okay. Or some SKU, some specific items I want to see, or I don't want to see this specific items, where some sample SKUs that they have set up products for that you do not consider in the sales, that you don't want to consider them as sales. Some freebies that you want to give, or some $0 items will be there. So those kind of requirements will be provided. Yes. Some of them, the data quality checks you do. Business rules, the business will give you what they want to have the data. Okay.
Yeah, got it.
Yeah. So basically something like, quantity. Quantity cannot be decimals. It has to be a round number. I cannot have 2.5. Of course, if it is kgs, if it is a number item, then it can be, just the number. Okay. Or if it is a weight or something like that, then you can have decimals once, right? So those are the things. Invoice date. So date, what format? Specifically, most of the times you will have transformations on date elements. Sometimes you get epoch format date, just a long integer that you want to convert. You have to, when you're converting, which time zone you are converting to. So that is the most common use case when you do in transformations. PST, CST, EST, MST, daylight saving, GMT, epoch time. There are so many time zones where transaction started date time, processed date time, what time you received the event, right? So there are different timestamps that you have, so that you need to do a transformations on this kind of things.
Harun, I have one question here.
Mhm.
So this quantity column, right? Yeah, it cannot
Mhm.
be like a decimal, but can it be negative in this case? Like if they
No. So it depends, right? Again, so that's what I'm saying.
okay.
It depends. That is one of the business rules. So do you go and ask, so do you want to allow negative numbers or not? If business says yes, what does a negative mean? It is a return. Okay. How do you want to handle returns? Are you handling returns also in this process or not? If yes, is it expected to get returns in this file? Yes, you allow. No, you write a business rule. Now, if you are allowing returns, okay, negative means return. Yes, I want to allow negative. Yes, you can allow negative on that. So that's the business rule that you want to confirm with.
Okay.
That they want to allow, yes, you will write. Otherwise, you will write the business rule to raise an error if it is negative. or zero quantity? Do you want to allow zero quantity? What does zero quantity mean, right? So what does unit price zero means? Do you want to process that and write it to a separate table? Basically when bad data comes in, right? So whatever these rules fail, you will also just not ignore them. You will also write it to a separate log or a separate table where you go and look at that and then send it back to the source systems or some monitoring business who's looking at this. Say you send them a report, hey, these are the errors that we are giving. This is the bad data that we are coming. You send it back and get it fixed, right? So you cannot just ignore the bad data. Invoice date, yeah, I see here you have cast as timestamp. Invoice month, yeah, invoice month is December. So some things like these, you do transformations because it will be useful when you want to do aggregations based on the month. Okay, so you can directly use this column instead of again doing the transformation while you are doing the aggregation. That's good. Invoice month, invoice date, revenue, temporary view. Yeah, here. Spark.sql, interesting. You can do this, or you can read the table and then use the data frame, or you can actually directly write the SQL. You don't have to do spark.sql. You can write a SQL in the cell and then convert it to a data frame. Right? We have seen, so and see here. If you write this SQL, right? This is automatically stored in this data frame underscore SQLDF. What you can do is create a new cell under this and then just say df gold qp country equal to underscore SQLDF. So you will get it into the data frame, whatever variable you need. And basically this is the data frame. You're just assigning it one new variable because next time you run another SQL, again, it will be stored in the same variable. So it will overwrite. Basically, you can store that in a different variable and then you can continue writing, SQLs. But this is also fine. That's why I said there is no one way of doing it. You can write SQL, you can write spark.sql, you can write data frame dot all Python transformations also you can do like that. It's just a hack. You're doing a Python, but you're actually writing SQL within that SQL. But end of the day, all of these will go through the same processing. There is no difference in execution. It's only how you write the syntax here, but what it understands underlying, even if you write %SQL or even if you write spark.sql, even if you write df data frame dot transformations, everything converts to a SQL while it is processing. When we talk about Spark internals, we can talk about it. Everything gets processed through the adaptive query execution engine, that flow. Okay. All right.
Arun, one quick thing that I noticed,
Yeah.
when reviewing a couple of the notebooks, right? I think there is opportunity to use the merge schema, right? In this
Yes.
notebook. I think do you want to highlight that? Where where you have your base schema and then you're creating the new columns, with some transformations, and you probably write into a different data frame, and then you can merge those two data frames in a single step, right?
Yeah, merge schema will, we have not covered that here. Oh, yeah, merge
Okay.
schema. We have
Okay.
not covered that, but when we do the Databricks Delta, I think,
Okay.
so there we are covering this feature. Yeah, some of these
Okay.
small things we have to first talk about,
Mhm.
but it's good they have used. But
Yeah.
what does merge schema do? We will talk about that, how we can
Okay.
use that
Yeah.
in the Delta. All right, we'll do that. That's good. Okay. I think we are at time. So, Subhashni, we will go through your notebook tomorrow. You can walk us through. I will also go through that notebook today, and then we can set aside some time tomorrow for your notebook for us to walk through.
Yeah, sure, Har.
Okay. Yeah. All right. I think that is all for now. I will send out the recording, go through the streaming, go through these 3 examples, and I will also publish the notebook, those 2 notebooks. You can run them. Everything on the community edition, it will run fine. So tomorrow I will show some Azure Event Hubs, streaming with Azure Event Hubs, so that we can. I will demo you using the other account, and we will also go through notebooks tomorrow. All right. Anything else? Anybody? Any questions? Comments? Yeah.
Can you provide this recording right after the class?
No, it takes some time for processing because we are doing it on the local.
Okay,
At least it takes couple of hours.
Okay, no problem.
When we upload to YouTube, and then first it has to convert on the local machine, then upload on YouTube. Then it goes through some MP4 quality processing and all of that. So yeah, it takes couple of hours, but yeah, I'll try to publish as soon as possible, as early as possible.
Yeah, okay.
Okay, maybe in couple of hours, I will upload that. Okay. Any other questions? Hitesh, are you guys following Hitesh, Mandeep, Murali? If you need anything, reach out to me or Shiva. If you want to cover any of the earlier basics classes, I know. I thought you will reach out whenever you have time. We can set up a separate session for you guys to catch up. What if you see any gaps, from the earlier sessions after you watch those recordings.
Yeah, okay.
Okay. All right, guys. Thank you so much. Appreciate it. Please go through the recordings and run these notebooks. We will continue tomorrow. Okay.
Thank you.
Thank you all.
And whoever has not yet done the batch processing notebooks, please go ahead and try doing that. It's good to have the hands-on experience. Okay. Thank you. Have a good day. Rest of the day. We'll meet tomorrow.
Thank you all.
Thank you.
Bye.